Mathematics is a language which every branch of science speaks to communicate with every other branch and across the globe, regardless the language which scientists speak at home. Just like any other language, this language has structure of sentences as well. We studied algebraic expressions before. Now we are going to define algebraic sentences. When two algebraic expressions are related by any of the symbols less than, greater than, equal to, not equal to, etc., they form an algebraic sentence. Types of algebraic sentences. Obviously, if the statement is true, then the sentence is said to be true sentence. Like if 2 plus 3 is equal to 5, then this is a true sentence. But if 4 plus 5 is being expressed equal to 12, that is a false sentence because 4 plus 5 is not in fact equal to 12, it is equal to 9. So this sentence is false sentence. If we write a sentence like 2x is greater than or equal to 11, it is called an open sentence. The reason, because we don't know the value for x. It could be true for some values of x, but it could be false for other values of x. Therefore, it is called an open sentence. And if the sentence involves the equality sign, like sentences involving the equality sign between two algebraic expressions are called equations. And linear equation, this is the most important concept in algebra, at least at this stage. Equation whose graph is a straight line is called a linear equation. So if we graph the equation and it becomes a straight line, then that equation is said to be a linear equation. So what kind of equation that would be? There will be no powers of x or the other variable y. Those are the characteristics. And there will be no product term of both the variables x and y. That characterizes that what a linear equation should look like. No product term of the variables and no higher powers of x or y, the other variable. Now we take a look on the definition of system of linear equations. Group of equations expressing more than one relations between same set of variables is called a linear system of equations. So this topic is called the mathematical modeling, and this is the most important. I can say with utmost responsibility that this is the area where students all across the world, they struggle, and if you develop skills in this area, you are one step ahead of everyone else already. And in this step, what we do is we take a social situation, we take a real life situation, and we try to translate it into a mathematical model. So, in other words, what I'm trying to say here is we translate the ordinary human language into a mathematical language. So, this is a transformation from the ordinary human language to one mathematical language. As you know that there are hundreds and thousands of human languages, but mathematical language is only one all across the world. Therefore, no matter which real situation you are dealing with and which language is being this situation expressed in, but its equivalent mathematical model would always be same, doesn't matter where you are. So let's try doing this question first. A number consists of two digits. The digit at tens place is 2 times of the digit at units place. the digit in the numbers are interchanged to form a new number. The sum of the new and the original number is 99. Find the system of linear equations to model this situation. So here in this statement, this is an ordinary English statement. So our steps would be, before we get started with the steps, let me first explain what a two-digit number looks like. All the numbers greater than 9, like 10 to 99, these are all two-digit numbers. For example, 23. 23 is a two-digit number. Here, 3 is the unit digit. This is the unit digit. And 2 is the tens digit. So this is the tens digit. And why is it called tens digit? Because if we were to write this number in this form, we will multiply 10 with the tens digit and 1 with the unit digit. 3 times 1, that would be equal to 23. You can see that 3 times 1 is 3 and 2 times 10 is 20. 20 plus 3 is equal to 23. So this is how we write a two-digit number. And you can see that number at ones or unit digit is independent of number at the tens digit. So if this could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, the number at the tens, at the second place, at tens digit, could be some whatever between 0 and 9. So if this is a variable x, then this could be whatever, but we can name it as y. But if we were to write the number, we would write as x plus 10 times y. Just like we wrote 3 was the unit digit and 2 was the 10 digit, we wrote 3 plus 2 times 10. Similarly, if the number consists of x and y, then we would write the number as x plus 10 times y. So this is the background. And now we'll get started with the question. We only need to write the mathematical model. At this time, we are least concerned about its solution. So here we say that a number consists of two digits. So let's assume that the unit digit is x, we say, and the tens digit is y. We write this in the form of table so that we have clarity of thought and these facts are organized in tabular form. The tens digit, the digit at tens place is 2 times the digit at units place. So the digit at tens place is 2 times the digit at unit place. So if there was 2 on the unit place, then what would be the tens place? That would be 4. If unit digit was 3, then what would be tens digit? That would be twice. That is 2 times of the digit. So if there was 3, then tens would be 6. So we already got this information here. Let us write down this relation. And we are looking for two relations. One relation we have found that y is equal to 2 times of the unit digit. And if unit digit is 1, then y is equal to 2x. Let's write down this relation. And now we will be looking for the second relation as well. So we utilize this piece of the information and we wrote one relation. Now it says the digit in the number, the digits in the number are interchanged to form a new number. So here if x is the unit digit, y is the 10 digit, what is the number? So the number here is equal to x unit digit plus 10y. Now the information here is the digits in the number are interchanged. So if y becomes the unit digit and x becomes the tens digit, then the sum of the new, okay, if now the position of x and y is changed, then of course the new number would be something different. Number, and this is the, of course, the new number. This new number would be equal to 10x plus y, because y was tens digit, it has become now the unit digit, and unit digit has become now the tens digit. So here we have two numbers. The sum of the new and the original number is 99. So the second relation what we have here is that 10y plus x plus 10x plus y is equal to 99. Is equal to 99. We can now simplify this and write down the relation, and that would become 10x plus x will become 11x. 11x plus 11y is equal to 99. And if that is the case, so here we have 11x plus 11 y equal to 99. And if we were to divide this by 11 on both sides, we will get x plus y equal to 9, and this is relation number 2. You can write this as any of these three as relation number 2, but this is the simplest form. Therefore, we have the model, and this is called the system of linear equations. Now, if we take a look on the next question, the difference between numerator and denominator. So obviously here, if something is the numerator, so let's write as numerator and let's write down as denominator. And if x is the numerator and denominator is y, the difference between the numerator and denominator of a fraction, so if x over y is the fraction, then what is the difference? X minus y is the difference of the numerator and denominator, and that is given is equal to 6. So we already found one relation here. If 2 is added to the numerator and the denominator, so new numbers. So these were the numbers, and now the new numbers are, according to the new information, if we add 2 to the numerator and the denominator, so the new numerator will become what? X plus 2, and the new denominator will become what? That will become y plus 2. And according to the given statement, it says that if 2 is added to the numerator and the denominator, the new fraction is 3 by 2. Therefore, what we have here now is x plus 2. What is this is given here? X plus 2 over y plus 2 is equal to 3 over 2. So if this is so, then we cross multiply, and for cross multiplication we multiply 2 on this side. This becomes x plus 2, and on the other side it becomes 3 times y plus 2, and we will simplify. This will become 2x plus 4 is equal to 3y plus 6, and this will become 2x minus 3y equal to 6 minus 4, and this will become here 2x minus 3y equal to 2. This will become the second equation, and we're gonna name it as equation number 2. So equation 1 and 2 make the system of linear equations. So this is what we wanted to. We needed to transform an ordinary English language into a mathematical language, which we have produced in the form of two equations. We call them equation 1 and equation 2. And now the next one. The sum of two numbers is 72. We don't know what those numbers are. So let's assume first number is x, and let's assume that second number is equal to y. Let's utilize this situation, and the information given is the sum of two numbers is 72. It's obvious what is being said here is that x plus y is equal to 72. One number is 3 more than 2 times of the other number. So what is 2 times of the other number? Let's call this y as the other number. So what would be its 2 times? Obviously, the 2 times of this number would be 2y. So here, let's write it down here. 2y here. And the first number is still x. So what is it saying? Is the first number is 3 more. 3 more than means that the difference between x and 2 times of the second number is 3. So therefore we have equation, the difference here is x minus 2y is given that this is equal to 3. One number is 3 more than 2 times of the other number. So this difference is given equal to 3. So let's write this as relation number 1, and let's write this as relation number 2. So this equation 1 and 2, therefore equation 1 and equation 2 make a linear system of equations, make a linear system of equations, and there is nothing better than practice. So if you will have more statements like this, the real life situations in language of your choice, whatever you are comfortable, then translate that real situation from your own language to a single mathematical language that is spoken all over the world. Now here the last question is that Sarah invested $2,000, a part of it at an annual interest rate of 8%. So it means that $2,000 is divided into 2 parts. Some of it is invested at interest rate of 8%, and the other is invested at the interest rate of 10%. So first part of 2000. So first part, let's say that a part of 2000, we call it x, and the second part is y. Now what is the relation given here? Because the total $2,000 was divided into two parts. So isn't it obvious that if we mix up the part 1 and the part 2, the total must become $2,000. Therefore, we have here one relation. We can say that x plus y is equal to $2,000. So that's wonderful. We can call it as equation 1. Now, this x part 1 was invested at 8%. So if this was invested at 8%, so what would be the interest earned there? That would be 0.08 times x. And what would be the interest earned at the part which was invested at 10%? That would earn the interest 0.10y. And after a year, the total interest was $190. So if we add up the interest earned from the part 1 and we add up the interest earned from part 2 of our money, the total must come to 190. So here it would become 0.08x plus 0.10y is equal to 190. And let's call this as the second relation, or equation number 2. Here, equation 1 and equation 2 make up a linear system of equations, a linear system of equations. And I will conclude my lesson at this question, but I would say with utmost responsibility that this is the most important skill you can learn as a student of mathematics. And the way you can learn this skill is you try more and more questions. Practice, practice, and practice. That will make you perfect. And if you have any questions, please post your questions and I will be happy to answer those.